Hey, welcome to Connecting with Code Week 2. We're excited to have you here. We're going to be using Scratch again, just like we did in Week 1. If you didn't see it, there was a whole Week 1, which was an introductory series of videos that use Scratch. Those videos are focused for like a K through 3 audience, but to be honest, they're also for anyone that's never coded before. This week is going to be like more intense, right? So this week is for 4th through 8th graders. If you've never coded before and you're in that age range, then you're in the right place. If you're worried about your coding, you could go back and work a couple of those videos from week 1, just to kind of like mention that, right? This series is also appropriate for older people as well, people that just want to learn more about Scratch. So what we're going to do is we're going to build a game today. You're going to follow along with me, and we're going to hopefully make some cool things. I want to introduce my campers. So I brought 2 campers that you might recognize from week 1. We'll have this guy introduce himself first. What's your name and how old are you?
Hello, I am Keegan Fisher, and I am 9 years old.
9 years old. So he's going to be going into 4th. So he's the age range at the bare minimum that makes it in here.
Hi, my name is McKinley Fisher, and I'm 11.
Cool. And what grade are you going into next year?
6th.
6th. So these are my 2 campers. We're kind of on the younger end of what this camp is really designed for, but we're going to make it work, right? So this material consists of 5 days, so there's 5 different videos. Today we're going to be doing something called lawnmower. So lawnmower is today's week 1 Monday activity. Tuesday is Dino Jump. It's kind of like the no internet game, if you've ever played that in Chrome. Irish Sheepdog is Wednesday. Slide Puzzle, it's probably our biggest game. It's going to be on Thursday. And then an advanced kaleidoscope. So if you were with us in week 1, Friday we did like an intro kaleidoscope, and we're going to be doing an advanced kaleidoscope this week. Do some acknowledgments before we get started. This material was developed by me. I'm a professor here at Rolls-Hulman. So this camp is brought to you by Rolls-Hulman. This year we're partnering with Mission College. So this material was co-developed by Bob Schaefer, so you won't see him on the camera here, but we developed the material together. So it's a partnership this year between Rolls-Hulman and Mission College to bring you this camp. So let's take a look at what we're going to build together today. So I'm going to start by showing you the solution. It's always kind of nice to know what our goal is. This game is called Lawnmower. This is inspired by Keegan, by the way. He's the lawnmower in our family. And so let's go ahead and take a look at the solution. By the way, I'll make a link to the solution available on the website, so connectingwithcode.org/camp. And so you can go look at the solution there if you want. But I'm just going to play it and you can watch it. So you can see that what happens is it starts off by planting grass. And so the whole field covered with grass. And then I'm controlling this mower with the keyboard keys. And I'm revealing a picture behind it. Now this picture happened to be a fairly grassy picture. I've got one more to cut up here. That was really loud. And so you can see that the idea of this game is that you click the start button and it plants all your grass. And then it's got a hidden picture behind it. Now sure enough, this time it randomly picked the same picture. I'm going to stop it and run it again. And so there's some hidden picture back there. It is randomly picking a picture, I promise. All right, so there it's finally a different one. And honestly, I don't know why it took so long to get a different image. But the idea of this game is that you'll make some secret image. So you're going to make a number of different wallpapers to put back there. And then you're going to lawnmower to reveal to reveal the solution, right? And each time it should be different. And you can make fun messages for people that you think are going to play your game. So let's say you're going to show this to your mom. Moms always like messages specific to them. And so you might say, I love you, Mom. So that's kind of how the game works. Makes sense? You guys ready to get started? So normally with Scratch, what we do is we go visit scratch.mit.edu. So I'm just going to type this in, scratch.mit.edu. And we typically sign in. If you already have a sign in with Scratch, then use it. If you don't, you just have to sign in over here. So if you haven't ever signed in, it'll probably look like this. and you'll have to click on Join Scratch if you don't have an account. If you do have an account, click on Sign In. Pause the video if you don't have an account and make one. You don't have to validate the email address if you don't want. It'll ask you to validate an email address. If you can do that, go ahead and do it. But you can't make public products until you validate your email address. So just kind of get that worked out. Now, normally what we do in Scratch, I'm just going to kind of show you this really quickly, is we click on Create, and we just start creating a game in Scratch. My hope is that you've probably already done something in Scratch before this camp. This is kind of an advanced camp, but if you haven't, it's okay. I'm just going to quickly tell you about the environment. So the environment is set up in a couple different sections. The section over here is the stage. This is like where your code runs, where things happen. Below the stage are the different sprites in your game. Some people call them actors. So here I've got a cat as an actor in my game, and I can move him around on the stage. And then the cat has code that you can write for the cat. That's obviously why we're using Scratch, because it involves a lot of code. He can have costumes, which are different images for this sprite. And then he can have sounds that he knows how to play. Just to really briefly do something, let's drag over one piece of code. And to run it, you can double click on it. That's like one way to run it. It's kind of the worst way to run it, but it is one way to run it. You can also go to events here. You can see that there's a number of different code blocks, and they're color coordinated. You can either click on these to get around, or you can scroll through here to find it. If you go to events and grab when green flag clicked, that's typically how these programs start. And so now when I click the green flag, you can see that he goes. Typically your programs will have loops, so I'm going to just quickly grab a forever loop here, and I'm going to stick it around that one. You can see that Scratch is more kid-friendly than regular programming language, because you drag and drop the code instead of actually like typing it. And then just to put one more command in here, I'm going to find one that says if on edge bounce. So right now if I run this program, you can see that it makes my cat go back and forth forever. That is typically how we start programs. We start from a blank slate. We add sprites, we add code, we build things up. For today's lesson, this is a more advanced lesson, we're going to start with a starter project. So instead of making you download the images for like the lawnmower and the grass, I'm going to give you a starting project. And we're going to learn a ton of things today. This is just kind of a list of the learning objectives for today. Learning about the environment, we kind of just did that. Learning about flow control statements, learning how to make clones. Even McKinley hasn't made clones. She'll be excited to learn about clones. And lots of good stuff with Scratch. So to start things off, what you're going to need to do is you're going to need to remix the project that I've got here. This project is called Lawnmower Starting Code. So you're going to have to go to this URL. This URL, I'll make it available in the email that I send out. I'll make it available on the connectingwithcode.org/camp page, so you can find it there. I'll also put it in the description of this video. If all those things fail, just type it, right? It's not that hard to type. When you go to, so I'm just going to go ahead and close this one. When you go to this page, it should look like this. So it'll say Lawnmower Starting Code, created by Fisher DS, that's me. You're going to have to click on Remix. Now what happens with Remix is it makes a copy of this project from Fisher DS and it brings it into your account. So now you have remixed this project. It also makes the name Lawnmower Starting Code Remix. Let's go ahead and change that. So let's just make it Lawnmower, and that's a fine name if you just want to delete what's there. If you wanted to type something else you could, but I'm just going to say Lawnmower. Whenever you get code from someone else, the first thing you need to do is you need to understand what you've got. So I'm going to go ahead and zoom in a little bit here so you can see it better. So what we've got is we've got two sprites. One sprite is called Robot Mower. The other sprite is called Grass Square. You can see that Robot Mower and Grass Square, they have no code, right? So there's no code that we're giving you. So really we just wanted to give you some images. We've also got a backdrop over here. The backdrop has no code as well. And the backdrop, you can see, has two costumes in it. One is called Lawnmower Connecting with Code, and then the other is just this blank XY grid. So we've given you two backdrops in here. Now, later in today's project, you're going to create a bunch more backdrops because these are going to be like the secret backdrops that you can reveal. You can make 2 or 3, and that's plenty, but you can make 10 if you really want it. And so just know these are the secret things that kind of make your game fun for others. For now, though, go back to the XY grid. All right, so that's the sprite. So we've got a mower, we've got grass, we've got backdrops, and we're ready to write some code. So to get started, I want you to click on the lawnmower. You know you've got the lawnmower selected because his icon shows up here, and also he's got a blue line around him. And then you could change his costumes or sounds, but obviously we want the code. So we've got a couple different goals for this game. Our first goal is actually going to start with the mower itself. And so the mower itself needs to move. So you can see that the mower always moves, right? And then what we do is with the left and right arrow keys, we change the direction that the mower is going. And so that's the goal of this project. So the mower, let's start with the basics. Let's start with events, when green flag clicked. So most projects start this way. This is kind of like the main function that gets called. So when the green flag is clicked, people will expect that's how they start your game. What I want to do when the green flag is clicked is I want to make sure that my mower always starts in that corner. So I'm going to go to motion, and I'm going to grab a go to XY. The nice thing about this command is that it knows where your mower is currently at. It's currently at -200, -150. And it's actually just going to go to -200, -150. The next thing I want to do is I want to put on a point in direction of 90. So when you run your program now, it looks like nothing happens. But if you move your mower somewhere different and then run your program, it's going to snap to that location. So far, so good? Let's see now if we can make this guy start to move. So the movement is going to need to happen forever. So the first thing I grab is a forever loop. I always joke with my younger kids that it's really like improper to tell some human to do something forever, but in code it happens all the time. So forever, do this thing. And forever, what we want to do is we want to move. So we're going to have move 3 in here. If you were to run it right now, it would work fine, except for you can't steer, right? So you could run it and it would do that. You could take it back and run it again. So we need to be able to steer using the left arrow key and right arrow key. So we need to know if somebody's pressing the left arrow key or the right arrow key. And I mean, you kind of heard the command we're going to need in the words there. So go to control and find an if statement. Again, if you're completely new to coding, some of these things will seem like a flood of information. But if you've done anything with Scratch before, you've probably seen if statements. The way an if statement works is it says if this condition is true, so this diamond means like condition, then execute the code that's in here. And currently there's no code in there. I put 2 of them on there because I know I need a left and a right. Let's do the conditions first. Conditions are very often in sensing. Sometimes they're in operators. We'll get that later. And in sensing, what we want to do is we want to find the right condition. You'll notice the conditions are the diamonds here. So there's like a touching color, a color touching color, all these things. Here's the one we want. Key space pressed. So go ahead and drag one of these and drop it over. By the way, you know it's going to go in there whenever the outline goes white, right? So some people try to like put the middle of it in there and it doesn't work. You got to kind of put the edge in there, and when it goes white, you drop it in. Now, obviously, space is not what we want, but that's why there's this little drop-down arrow on here. So click the drop-down arrow and change the top one to left arrow and the bottom one to right arrow. So when we press the left arrow, we want to turn a few degrees to the left and then the opposite with the right. Movement, you'll kind of get used to this. It's going to happen over in motion. And so in motion, a left turn, it kind of looks like a counterclockwise turn. So that is the left direction. And then the right direction is the opposite, right? So left and right. And the amount that I'm going to turn is just 5 and 5. And so now if you run your game, you should be able to use the arrow keys to drive your lawnmower around your lawn. And so it should be, I don't know, a pretty successful little fun game. Eventually, you will get bored of driving your lawnmower around because there's nothing to collect or nothing to do. I could probably drive it around for a while, but eventually I'd get bored. I can make it do donuts for a while. So what we need to do is we need this lawnmower to actually like collect grass, right? So you can see that the first thing that happens is that the game is all the grass gets planted, and then the lawnmower starts collecting it. So I think that we're ready to start planting some grass. In order to plant grass, if we kind of watch it here, you can see that it does a clone of this sprite called grass, and it puts it on. It does the whole top row, and then the second row, and then the third row, and it does it so fast it's almost like magic. It's not magic. You have to code it up to make it work. So what I want to do is I want to start with a little bit of math, because math is going to tell us where these pieces of grass need to go. It's going to tell us how many are in each row. It's going to tell us how many columns there are. And so we need to kind of do some math to understand what's going on. So the first thing that we need to do is we need to understand this piece of grass. So how big is this piece of grass? In here it says it's size 100. That doesn't really tell you how big it is. The costume over here says it's 60 by 60. Ooh, that actually does tell you how big it is. And in fact, if you look at this grid shows you how big the whole stage is. And you can see that here's 100 here. And so it's just a little bit more than half. So it's 60 by 60. So that's our first piece of knowledge. So how big is the tile? So what we're going to do is we're going to go through some slides to kind of do the math to make sure we understand things. And then we're going to get started in writing the code. And I'm going to use a whiteboard here. All right, so I got my whiteboard, and now I'm free to draw on things. So this square, we know that it is 60 by 60, so that's how big it is. We're going to need to know some other things in addition to the square. We're going to need to know how big the overall grid is. And so I'll kind of ask my campers, how wide do you guys think this grid is? Shout it out if you think you know the answer.
240.
So 240 was the first guess. 240 is a very reasonable guess. I'll say that 240 is almost right, but it's not quite right. Any other guesses? So I'll give you a hint. This side is positive 240. That side is negative 240. So how big is the whole thing?
480.
480, that's right. So this grid is, and I just kind of write it up here, it's 480 pixels wide total. So that's something that we're going to need to know. Let's do the same thing with the height. How tall is this grid from top to bottom?
360.
Is that what you got, Keegan? All right, yep, 360 is correct. So the y is 180. It goes to a negative 180. Oh, that's really hard to read down there. And so this thing is 360 tall. So we're just kind of like gathering some information. So the next question is, just so we understand it, how many will fit left to right? So this square is 60. There's 480 total, so your division skills are going to get tested here. So how many squares do we think are going to fit left to right? Keegan? Not quite. Sissy?
80.
So her guess was 80.
Oh wait, 8.
8. Yeah.
0.
Yep, no problem. So our goal is to fit on here 8 squares across. So if we were to kind of like divvy this thing up, we could divide it here and here. I realize my marker's not great. But there's going to be 8 different squares split up in here. Maybe I'll get a better marker here in a little bit. Next question. How many fit top to bottom? Oh, shoot, I jumped to the wrong page. I guess I've got the answer here. How many will fit top to bottom if it's 360? Keegan, can you read the screen?
6 squares.
6, yeah, that's right. So our goal, that's a marker. Our goal is to get 8 of them across and then 6 of them from top to bottom. So it looks like there's going to be kind of like a row here, a row there, a row here. So our goal is to make all that happen. Now we're going to start putting them in one at a time, right? So we're going to start putting them in. We're going to put in this one first, and then this one second, and then this one third, fourth, fifth, sixth, seventh, eighth. You get the idea. I'm not going to label all these. How many are we going to have total? What's the bottom number here? Can anybody figure out what we're going to have total? 48, that's correct. And so somehow I got off there. That's 15 and 16. So there's going to be 48 squares total. They're going to be set up with 8 in each row, and there's going to be 6 rows total. Now we've got to do some harder math. So where does the first one go? So in Scratch, what you care about is you care about the center of the sprite. So our first one that we're going to put in goes right there. So this edge has an X value of negative 240. The overall box is 60 wide. So what is the X value right here? So how much do we have to move over from negative 240, half of the box? And so what value in the X is that right there? You got it. All right, way to go, Keegan. All right, so Keegan just got it. Say it again for us, Keegan. Negative 210, right? So it just changes that by 30. So negative 210, that's going to be an important number. So the X center is negative 210 of that first tile. What's the Y? So the Y up here is 180 at the top. And of course we have to come down by 30. So what is the Y value of this first tile?
150.
150. Sissy got this one. All right, so that's our math, right? So this square right here, this slide right here, as soon as I erase all this junk, kind of summarizes our math. So we're going to have a total of 8 squares coming across, and we're going to have 6 squares up and down. And the first one is going to go at negative 210, positive 150. So that is kind of our strategy and our plan. So how do we make that happen? So what we're going to have to do is we're going to have to go back into our code, and we're going to make clones of the sprite. And we're going to put the first one there, and we're going to see if we can get that to work. And then after we put the first one on, we'll try to put on the whole first row. And then after we put on the whole first row, then we'll put on the whole thing. Sound good? So let's go back to our code. All right, so let's see if we can jump over into our code and make this thing work. So how do we get a square to show up there? Well, one way we could do it is we could just put it there, right? So, we could go until it's at the right spot. So negative 210, positive 150. And then we could duplicate it and make another one and put it in the right spot. That would totally work. But that's not how computer scientists work, right? So if you're making, multiples of something, but it's really kind of the same thing, what you want to do is you want to make a clone of it. And in fact, I don't care where the original starts at all, because eventually I'm going to hide the original. So I'm just going to put the original in some random spot. And what I want to do is I want to create clones of it and move it to a spot. So let's do this. Let's go over to our stage. So click on the stage here. Go into the code on the stage. And what the stage is going to do is the stage is going to be responsible for planting all the grass. So let's grab a when green flag clicked for the stage. And what he's going to do is he's going to plant grass. So to plant grass, what you want to do is you want to say create clone of grass square. So if you were to run this program now, what it would do is it would create a clone of the grass square. It's very unexciting because the place where it created the clone was in the same spot as the original. Does that make sense? So there's actually 2 of them now. There's the original and the clone. So we need to create a grass square somewhere else, right? So let's make some variables. So you can make variables in Scratch. Variables are very powerful in programming. They let you just save off a number so that it's referenced by a name. Click on variables. And we're going to make 2 variables. Click on make a variable. The first variable is going to be called grass x. So this is the x value for the grass. And then the next variable is going to be called grass y. So grass x and grass y, you can probably guess what these variables are going to get used for. Variables in Scratch, you can easily display them on the screen if you want, but you don't have to. So I'm going to click on this checkbox here, and what that does is that just makes it to where it's not displayed on the screen. So no big deal. I don't need it displayed on the screen. You still have the variable if it's not displayed. I just don't need the display. So here's my goal. Before I say clone grass, I'm going to set the x and the y. So I'm going to set grass x to negative 210. And I'm going to set grass y to positive 150. So those variables are going to get used. They're not used yet, but they're going to get used to tell this clone where to go, right? So I'm going to create X, Y, and a clone. Now I've got to go into the grass square to make it actually use those variables. So the stage right now is fine. I'm going to move from the stage to the grass square. You'll notice that every sprite has its own code, the stage has its own code, and you can hop around between them however you want, right? So like our mower has a bunch of things done. Our grass square doesn't have anything yet. Let's write our grass square. So let's go to events. Normally, you would use when green flag clicked. That is not the case for clones. Clones are a little bit different. So clones, you need to scroll down into control and find when I start as clone. It's kind of a neat event. So whenever I start as a clone, what do? Well, the first thing I want to do is I want to set my X and Y using those variables. So I go to motion. I go to set, go to XY. And I don't want to type in a number. I want to use those variables. So I go to variable, and I use grass X, and I use grass Y. So now when I run it, my backdrop is going to set grass X, grass Y. It's going to say create clone of grass square, and grass squares are going to go to that position. So if I run it now, you can see that there's now a grass square up at the top. So pretty exciting, I know, right? Now something that happens a lot with clones is we don't actually want the original. And so the original, actually, we want to hide it altogether. So what I'm going to do is I'm going to hide the original. You can do this in code if you wanted, but actually it's easier. You can actually just click on this little like no eyeball button, and now it's hidden. That worked, but now your clone is also hidden. So now we've got to show our clone. Does that make sense? So for when I start as clone, I want it to show. Show is in looks, and I scroll down to show, and I'm going to put it after the go to XY. I could put it before, it wouldn't really matter. There's just some chance you'd see it move, but I don't think you'd even see it. So now if I run it, you can see that my grass square starts up there. So we have successfully created one grass square. If you go up and try to mow it, nothing's going to happen, right? So like it looks like the mower goes under it even. And it's not surprising that nothing happens because we haven't like made anything happen. But we've got a cool setup now. So now let's go back to the backdrop. So if we wanted to make another grass square, I could duplicate it. You can do this too, just to prove that it works. But this is not going to be our final solution. We could just march over to the next spot. So if it was at negative 210 and we need to move over 60, what's 260? What's 60 moved over? Sissy, do you know that one? So negative 210, we're going to add 60 to it and go over here. So what's negative 210 plus 60?
Negative 150.
Negative 150, that's right. So I could do this, and it would make two squares. Now there's a glitch, right? You're like, wait a minute, Dr. Fisher, you just said that this was going to work. Here's the deal. This is what's called a bug, right? It actually is so fast that it makes this one, and it says, hey, start making this, and then it starts making this one, and they actually both got set to the second coordinate. So to fix this bug, sometimes that happens, we need a very, very short time delay after we make a clone. So I'm going to go into control, I'm going to grab wait, and I'm going to make it very, very short. So I'm going to do like 0.01, so very, very short delay. All right, by the way, I just went and helped Keegan with a problem. He had a problem where he was accidentally setting grass X twice instead of X and Y. Code, you'll find, is very, very good at doing what you tell it to do. And you have to make sure that you tell it to do the right things, right? So X, Y, X, Y. So this worked fine. By the way, you'll notice I didn't actually need to wait at the end because it was done. All right, so now our goal is to make a whole row of them, right? And we could obviously keep duplicating this, but eventually we would have 48 of these things, right? So we don't really want to do that. So what we want to do is we want to make a row. Because I like to teach you things, we're going to also teach you about a function. So we're going to make a function, which we can call and we'll just call make a row, and it'll just do it. So to make a function, it's in Scratch, it's called a block. So go to My Blocks, click on Make a Block, and we'll make this function, we'll call it plant row. So just plant row. So it's kind of like a verb, like plant, and then the thing that you're going to plant is a whole row. So plant row is our function. And so our goal is that we're going to use some of this code over here inside of our function to make it work. So let's go ahead and figure out what code needs to go into the function. So I kind of disconnected it over here. By the way, to call the function, you'll just say, when the green flag is pressed, plant a row. So a row is only about x's, right? So really what I want to do is I want to put things about x's over here. So the grass x, I want to put it over here. The grass y, however, I want to like set before I plant the row. So grass y says like, what height should I plant this row at? So I'm saying at 150, plant a row. And so to plant a row, what we really want to do is we want to make a loop. So loops are in control. Does anybody remember how many grass squares we have in a single row? How many do we put across? 8, that's right. So I'm going to grab a repeat of 8. And what I want to do is I want to create a clone of the grass square. And then to fix that little bug, I want to wait for a second. So I'm going to set the x to the starting value. I'm going to plant a grass. I'm going to wait this long. And then after I plant that grass, I'm going to change the x by some amount. So I'm going to scoot it over before the next one is planted. So go into variables. And we want to change the x by some amount. Any guesses as to what the amount's going to be?
30.
So the first guess is 30.
Wait, no, 60.
You said 30, so I'm going to try 30 first.
60.
So if I run it now, it planted them only 30 apart. Yeah, so we want 60. So this is kind of fun. So we can tell the y where it's at, and then we can call plant row. Now we could, this is again, I'm just kind of like showing you something you could do. We could change the y to a new value and call plant row again. So I'm going to bring the y down by 60. So Keegan, this is your math problem. 150 minus 60.
90.
90, that's right. So 90. So you can see that right now I'm planting a row at 150, and then I'm planting a row at 90. Now, to be honest, this wouldn't be too bad to do. There's only 6 of them coming. This wouldn't be too bad to just repeat. But we're computer scientists, right? That's not how computer scientists roll. We make loops, right? So how many rows are there total? Anybody want to say what that number is?
6.
6, yep. So we're going to grab a repeat 6. And what we're going to do is we're going to plant a row at a given y. So I'll tell you what, I'm going to go and clean up some things here. So we're going to set the y to be 150. That's where we decided that we'd start at the top. If you remember our math over here, that was the first one. And then we're going to plant a row there, and then we're going to change the y and repeat it 6 times. So take a minute and see if you can finish the thing that's missing here. So we're setting it to 150, and then we're going to repeat something 6 times. We're planting a row, but after we plant the first row, we want to change the y by some amount. See if you can figure out what it is, play with it, and see if you can get the whole field to show up. All right, so for my campers, McKinley knocked it out, and Keegan says there's a lot of code and you're going really fast, right? You're maybe somewhere in the middle. So the y of 150 plants a row here, and what I want to do is I want to go into variables, and I then want to, after I plant a row, I want to change the y, and I want to bring it down by 60. Now, in the y, if we want to come down, it's currently 150. If we want to come down 60, that's a negative 60. So you can kind of see how, I suppose I have to see if it works. With loops, you can make your code much shorter than if you had written the whole thing. So now you can see that it plants the row by row all the grass squares. Now it did plant it right on top of my lawnmower, which I guess is a feature. Eventually the lawnmower is gonna cut the grass. Now one thing that I don't like is, see how my lawnmower is like mowing while the grass is being planted? I actually don't like that. I want the lawnmower to just be hidden while the grass is planted. It'll actually make my computer faster too, right? So here's what I want to do. After I finish planting all the grass, I want to broadcast an event that says I'm done planting the grass, right? So this is how one sprite can communicate with another. You broadcast an event, and a broadcast event's kind of like screaming a message, like, I'm done, right? So real loud. So go into events and find where it says broadcast message 1 and put it down here at the bottom. So it's making all the rows, and then when it's done, it's going to broadcast something. Right now it's going to broadcast message 1. That's not a very good name. Let's call it like done planting, right? So you can write the word done planting any way you want. You could say done and planting. You could say it like that. I choose to name my variables, my messages, my anything, using a style that computer programmers use. It's what's called camel case. And so things start with a lowercase variable, and then there's no spaces between words. You just use a capital to indicate that a new word started. So done planting. There's nothing special about that. I'm just showing you cool things that computer scientists do, right? So I broadcast done planting. And then over here on the lawnmower, you can see that he does a lot of things when the green flag is clicked. Here's what I'm going to do. I'm going to say, when I receive done planting. So all this stuff can happen when he receives done planting. So I can move him over here. In fact, if I want to, I could go a step farther. So you could run him now, and he'll just kind of be stationary until it's done planting. If you wanted to, you could go one step farther. You could go into looks, and you could hide him when the green flag is clicked, and then show him only when he's ready to start moving, right? I personally choose to put the show after his X and Y have been set, just so there's no chance of like seeing him in two places. But now if you run it, you can see he's just not there, and then he starts moving once all the grass is done. Now you can't see him moving because he's underneath my grass. I'm kind of surprised that he's underneath my grass, but it'll be fine. So things are going really, really well. By the way, in coding, you should always remember to save, but Scratch does save automatically for you. If you ever want to save, though, you can click on File, Save Now, and it'll save it for you. So we're doing great. The question is, what now, right? So right now, when the lawnmower goes, he's underneath the grass, but you can see in the real game, when he touches a grass square, it should go away. So whenever you're coding, you have to figure out whose responsibility is that. So who's responsible for detecting when the grass is touching the mower? Whew, that scared me. Who's responsible for detecting when the grass is touching the mower and then making it disappear? You could put that responsibility on either side, but since it's the grass that's hiding, I'm going to put that responsibility on the grass, right? So let's go to the grass. So right now the grass isn't doing anything. The grass just shows up and then it just sits there like this. And so really what the grass needs to do is the grass needs to detect if it's touching the mower. And if it's touching the mower, then it needs to hide, right? So let's go to control. One mistake that people do all the time is they stick an if statement straight on the bottom here. That would be pointless. And the reason it would be pointless is because it would literally check it one time when the program runs and then never again. We want to forever check for that. So I'm going to grab a forever loop first, and then I'm going to put an if statement inside of that. So I want to forever check if I'm touching the mower. And if I am touching the mower, then I want to do stuff, right? And so how do I detect if I'm touching the mower? It's one of these conditions. It's in sensing. And the one that you want is actually touching mouse pointer, which is kind of crazy, but it's got a drop down arrow. And so we want to say if I'm touching the robot mower. So now the grass, it's his responsibility to check if he's touching the robot mower. If he is touching the robot mower, we want to score a point basically so that we can keep track of how much has been mowed. And we also want to go away. So those are the two things we want to do. Let's go ahead and score a point first. So to score a point, we're going to need a variable. So I clicked on variables, make a variable. And so you can name this variable whatever you want. I'm going to call mine grass cuts. You can call it num grass cut, whatever you want to do. This variable, you'll notice that I chose to name differently, and that's because it will be visible, like on my screen. So if it is visible, then I try to make it like human readable, right? So num grass cut. So it's going to show up here. I could hide it if I wanted, but actually for now I'm going to make it visible. All right, so whenever you make a variable, there's a couple things you have to do. You have to create it, so I've created it here. You have to set it to 0 somewhere, or set it to some initial value somewhere, and then you also have to increment it. Really quick, I'm going to come back to this code. I'm going to go into the backdrop, and I'm going to grab a set num grass cuts to 0 over here. Now, I could have reset this variable in a couple different places. I chose to do it over on the stage. So I start off saying num grass cuts is 0 on the stage. I think that makes the most sense. And then we've got to increment it. So now I hop back over. You can see how I hop between code all the time. Hop back over to my grass. And I'm going to change num grass cut by 1. And so it's going to increment how much grass I cut. The other thing I want to do is I want to hide this piece of grass. What I'm going to actually do, instead of just hiding it, I'm going to delete it. Go into Control and find Delete This Clone. So you can see that when I start as clone, I do all these things, and if I touch the lawnmower, then I delete myself. So now, for the first time ever, we should be deleting grass, right? So if I hit the green flag, I can now mow the lawn, which is cool. Things are going really, really well. So the next thing I want to do is I want to change the background image. So you can see that right now I'm mowing, and my user is not at all surprised or delighted because the background image is just always this grid, right? If I run it again, it's still just the grid. Also, you'll notice that nothing happens when the game wins. It was playing that super loud sound for me earlier. So we want to create some backdrops that will surprise and delight our user. So here's what we want to do. Go into backdrops. The first thing I want to do is I want to create a few different backdrops. So go into backdrops. You can see that right now there's one. It's called lawnmower connecting with code. So this is one of the things that we might put in there as the secret backdrop. But we can put more on here as well. So do this for me. In the lower left where it says choose backdrop, just click on this circle. And you can put in any backdrop that you like. So I'll put on hearts. You could choose to put a message in this heart. So you could say, love you, Mom, or Dad. We don't have to be specific about one or the other. We haven't taught you about drawing yet, but I think that it's fun to just try to figure things out. So there's one. That one says, love you, Mom. I'm going to make another one. Maybe I'll make a jungle. You could put things on here if you wanted. You could put text on here. So this one I'm going to say, welcome to the jungle. By the way, you can do things like resizing. You can play with different colors on things. You could do whatever you wanted. I'm not planning in this lecture to help you make cool backgrounds because I just want you to play, right? And so pick whatever you think would be a background that's fun. Maybe you'll give a message like, can we get into the pool? So you could say, hey, Mom, play this game. Or hey, Dad, play this game. And then it would expose this question of, can we get into the pool? So you can see that right now I have 4 possible hidden backdrops. I could keep making more. They don't have to be customized, right? So I could just put on one of these images. If you know how to do it, you can also get things from the internet. Again, not going to show you this today. And then you could upload that image here, so you can put like a picture of yourself on there. That'd be kind of fun to do. And make as many as you want. I currently have 2 through 7 as options. So I think that that's enough for me. So I'm going to give my campers just a minute to make a few more, and then we're going to move forwards with the code. All right, so my campers went in and they added a bunch of grids. Let's look at the solution real quick to review how this is going to work. So while you're drawing the grid, it's some backdrop. And then as soon as the grid is done, it switches to some secret backdrop, right? So it's while you're drawing, it's a grid, and then it changed to some secret. This one always confuses me. And so that's our goal. So let's go into our code on our backdrop. So backdrop code. So when the green flag is clicked, I want to start off on the grid. So I'm going to go to looks. I'm going to put in a switch backdrop to XY grid. So that's kind of like my first grid. And so right now, if I run it, you can see it switches to that grid, but it's going to stay as that grid based on the code that I have right now. So let's, after it's done drawing, let's switch it, right? And so the moment when it's done drawing the grid is down here. So just before, let's grab it right there. Just before we broadcast this event, let's switch the backdrop to something different. Now we could hard code that, but then that wouldn't be random, right? So we could say like switch to hearts, but now every time you play the game, it's going to switch it to your heart, right? So we want to randomly pick that background. And so that's where operators come in. And so we want, in operators, pick random. Now one nice thing about costumes is you can refer to them by name. So this one was called hearts, this one was called XY grid, or number, right? So I could also say switch to number 1, and that would be the XY grid, or number 2. So what I want to do is I want to decide how many random things do I have. So for me, my first value is a 2. So I want to pick a number between 2. And then for me, it looks like I've got a 7 in here as well. So pick something between 2 and 7. So it'll always be the XY grid while it's drawing. So it's always the XY grid while it's drawing. But then after that, it's random. Its random number generator is not amazing. You might see the same thing a couple times. But right now it's the heart. And then if I run it again, this time it looks like it's the jungle, right? So it says welcome to the jungle. So it's kind of a neat little reveal game. By the way, when you stop the game, if you stop it manually, it will just show you the rest of the board. I consider that a feature, right? So not worried about it, but that is how the game works. So every time it's different. Now, the last feature that we'd like to add is when you finish mowing the lawn, I feel like something should happen, right? So like I finished getting the last square, but right now in our game, nothing will happen, right? So we hit num grass cut 48, but nothing happened. And as you might recall from the solution, it plays that really loud, scary sound. Do you guys remember that?
Yes.
So let's add code. This will be our last feature that does something when the number of grass cut is equal to 48. So somebody has to be responsible for this, right? Who's going to be checking if the num grass cut is equal to 48? We could put it in a number of places. We could let the grass check for it. That seems a little strange. We could let the background check for it. That would be okay. The only thing about the backdrop is it doesn't have a forever loop, right? So we'd have to make one. So what I'm going to do is I'm going to have the robot mower check for it. Just because he's got a forever loop, he's always present. So I'm going to go into the robot mower, and he's going to be the one that checks for game over. A check is a control if statement. So go ahead and grab an if statement here. And so if some condition is true, then run this code in here. Normally our conditions have been sensing conditions, but this time we're going to do something different. We're going to go into operators, and we're going to find the equals operator. And so we're going to say if the thing on the left is equal to the thing on the right, then run this code. And so one of them should be the variable num grass cut, and then the other should be the number 48. So 48 is the special number, which means you've cut all the grass. So when that happens, we want to play a sound. If you go into the Sounds tab, you can see that the lawnmower right now, apparently he doesn't have any sounds that he knows how to play. So let's pick a sound that we want him to play. So to pick a sound, I'm going to click on Choose a Sound down here. And the one that I played in the solution is ta-da. So I'm going to pick ta-da again. If you would like to pick a different sound, you just kind of hover over it, and it'll play it for you. And you can listen to the different sounds. But I think ta-da is a pretty good one. If I hover over it, you can see it's this nice loud ta-da. So once you've found the one you want, just click in the middle of it, and it'll add it to this sprite's sound library. So now this sprite is capable of playing the ta-da sound. Now we've got to do it in code, right? So go into code, go into sound, and find where it says play sound ta-da until done. So I'm going to play sound ta-da until done. Now after I play the sound, I want to finish the game, right? So the game's going to be over. So I'm going to go to Control, and I'm going to grab a Stop All. So this is going to play a sound, ta-da, really loud, and then it's going to shut the game down. So the game is over at that point. I think I'm going to run it and see if it works. If it does work, then I'm going to call myself pretty happy about it. So to test it, I kind of have to just do all the mowing. So I'm going to mow. By the way, it's your game. If you want to speed up the mower, a lot of people like to do that. Feel free to go ahead. So all right, so I'm at 44. I can get the last bit. That was some seriously loud ta-daing. Totally worked. So it says ta-da, and then the game finished. My game is done. What I like to do as my last step is I like to share it publicly. So I'm going to click on this share button up here. You'll only get a share button if you have created an account and validated an email address. But I like to do that. And then right now in the instructions it says use the arrow keys to mow the lawn. I think that those are lovely instructions. That must have come from the remix. And what I love to do is that this URL now is something that you could share with friends and family. So you can share this with whoever you want. So you just copy this URL and send an email to grandma and say, check out the cool game that I made. All right, so I've got a few closing remarks I want to make, but actually I want to see how my campers are doing first. So we're going to go see how McKinley and Keegan did, and we're going to check out their games and see how they came out. All right, Keegan, let's go ahead and see a demo of yours. So it looks like you've got the lawn set up, which is great. Yeah, the only real area for creativity in this game is what is the hidden thing behind it. Some games will have an opportunity for a lot of creativity, but this one is really just the background image. So it looks like Keegan has a secret passage as one of his background images. I'm sure he's got quite a few. Let's go ahead and have him finish just so we can hear his sound. Lovely. Great. Go ahead and click play again just so we can see that it switches to a different image, and then we'll let Sissy go. So he's got some other image. Oh, it looks like that was the connecting with code one. Great. All right, McKinley.
Oopsie. I don't know why it did that.
So a bug in there that I'm sure that we'll be able to fix. But it looks like she has a functional lawnmower game. It looks like she's got a lot of fun background image. It looks like she made one. Wow, very complex. Did you make that yourself, McKinley?
It was on a different game I made.
Oh, she used a kaleidoscope version to make that for herself. Great. Great. Do you guys have fun? Oh, there's your kaleidoscope program where you make backgrounds. Do you guys have fun with the lawnmower game today?
Yes.
Is the challenge of the games this week quite a bit higher than it was last week?
A bit.
All right, so we hope that you had fun today. The real goal is that you learn that coding is fun and that you can do this. You can see how we used a lot of math skills. Math and code, man, they go hand in hand, right? We learned about doing things in sequence. We learned about how different sprites have their own code. And we also learned one of the best tricks is that you can have one sprite with many, many clones of it. So it was a huge first day. I chose to put a big one right off the go because this week is going to be a little bigger, right? When you watch these videos, it might take you a few settings to try to get through them. But my hope is that you learn a lot and you will be able to apply these skills to your own Scratch games one day. We hope you enjoyed being with us. We've got a lot of additional fun set for you for the rest of the week, and we can't wait to see you then. Bye.